Question 1. Find the highest common factor of this set of numbers. Let's start with a table. Put the numbers in the column there, and remember we're looking for the highest common factor. Okay, what I want to do is to put the lowest prime factors in each of the columns, then the higher ones, and so on, until I've got what I want is 2's, then 3's, then 5's, and so on. 12 divided by 2 gives us 6. 6 divided by 2 gives us 3, so there are two 2's in 12, but I'll leave the 3 for the moment because I want to see how many 2's there are in the other numbers. 18 divided by 2 gives us 9, so there's only one 2 in 18. 36 divided by 2 gives us 18, so there are clearly two 2's in 36. And 90 divided by 2 gives us 45, so there's only one 2 there. So that's all the 2's in this set of numbers. So we can now go back to the 12, where there's a 3 in the 12. Now the 18 divided by 2 is 9, so there are two 3's in 18, and equally there'll be two 3's in 36. 90 divided by 2 is 45, and 45 is made up of 3 times 3 times 5, so we can write that in there. Now, for the highest common factor, which is what we're looking for, we're interested in all of the columns that are fully populated. We've got the 2, and we've got the 3, and that's all that's fully populated, so the highest common factor is 2 times 3, which is equal to 6. And that's the answer for question 1 part A. Question 1 part B, we're asked to find the lowest common multiple of a set of numbers. Well, to start with, we'll create a table as in the previous example. We'll put the numbers in, and we're looking for the lowest common multiple. And we'll factorise in exactly the same way. So 12 is 2 times 2, 18 has got one 2 in it, 36 has got two 2's in it, and 42 has only got one 2 in it. 42 divided by 2 gives us 21, which is odd, so therefore there's only one 2. Now we'll look at the 3's. There's one 3 in 12, two 3's in it, both 18 and 36. And then in 42 divided by 2 gives us 21, so there's one 3 and one 7. Now, this time we're looking for the lowest common multiple, so it's any column that's in the table here. So there's the 2, the 2, the 3, the 3, and the 7. So those are the factors in the lowest common multiple. 7 times 3 is 21, times 3 is 63, times 2 is 126, times 2 is 240, 252. So the lowest common multiple is 252. Question 1 part C. Evaluate in terms of powers of primes. Now, evaluate generally means find the value of, but this says in terms of powers of primes. So at the end of this we need 2's to a power and 3's to a power. Right, so let's break this down into pieces. First of all, we've got the 3 cubes, so we'll leave that there. But 4 is not a prime. 4 is 2 times 2. So let's expand that to say that that's the 3 there, you see? And there's the 4, which is 4 cubed, so that's 2 cubed times 2 cubed. Okay, now we'll look at the denominator. The 2 to the minus 4 and the 3 squared are both prime factors, but 24, well, that's made up of 2 times 2 times 2, which is 8, times 3, which is 24. Right, let's gather all the terms together and reorder them with the smallest on the left hand side. So we've got 2 cubed times 2 cubed, so that's 2 to the 6, and we've got 2 cubed and 2 cubed is 2 to the 6, 3 cubed remains the same. We've got 2 to the minus 4, 2 times 2 times 2, which is 2 cubed. And then we've got 3 squared and a 3 there, which gives us 3 cubed there. We've got a 3 cubed in the denominator and a 3 cubed in the numerator, so they can cancel. We've got 2 to the minus 4 and 2 to the plus 3 in the denominator here, so that leaves us with 2 to the minus 1, so that 2 to the 6 over 2 to the minus 1, 6. So 6 minus minus 1 gives us 2 to the 7, and that's the answer for question 1 part C. Question 1 part D. Rationalise 1 over the square root of 17 minus 4. Now, when you meet a problem of this sort, we want to have no square roots on the denominator if we can avoid it. Now, before we start trying to work this out, let me just remind you of something. the difference of two squares. I've got a times a, which gives me a squared. I've got a times minus b, which gives me minus ab. I've got b times a, which is going to give me plus ba. And then I've got b times minus b, which is going to give me minus b squared. AB and BA are obviously the same, so they will cancel. So I've now got a squared minus b squared, or if I write that again, I've got a squared minus b squared is a plus b times a minus b. Okay, this is the difference of two squares. That's a square, that's a square, and I can write it out as those brackets. So bearing that in mind, let's look again at the problem. Root 17 minus 4. So if I multiply root 17 minus 4 by root 17 plus 4 over root 17 plus 4, I've now got here the difference of two squares effectively, haven't I? I've got root 17 minus 4 times root 17 plus 4. Well, if I expand that, root 17 times root 17 is going to give me 17. Minus 4 times plus 4 is going to give me minus 16. 17 minus 16 is 1. So I've got root 17 plus 4 over 1. And obviously anything over 1 is the same as you don't, and obviously we don't need the 1. So that means that 1 over root 17 minus 4 can be rewritten as root 17 plus 4, and root 17 is not the sort of thing you would do in your head, so that's how you would leave the answer.